Hello guys, good morning. How are you all doing today? Last time you realized we talked about Pythagoras theorem. And when we talk about Pythagoras theorem, we talk about using b squared equals to c squared plus a squared. That's correct. When we talk about the longest side of the hypotenuse is equal to the sum of the square of both sides. That's Pythagoras theorem. And this is actually geometry, mathematics, and trigonometric ratio. At this time, we'll be talking about using SOHCAHTOA in solving a right angle triangle that has angles in it, probably degrees. Let's say 35 degrees, 55 degrees, and 50 degrees. So using SOHCAHTOA, SOHCAHTOA is written in this form. So I have SOHCAHTOA. So we can separate it like this. Okay. So the S signifies sine. Sine, the O is opposite, and the H is hypotenuse. Okay, and then the cat is cosine, which is equals to adjacent over hypotenuse. Okay, and then we have TOA, the T stands for tangent. Okay, tangent is equals to opposite over adjacent. That's correct. I know you know this by now. So let's try doing this problem. So we have this problem. This is number 90, and here is 55 degrees, and here is 20, which is hypotenuse. Here's the hypotenuse, and here is the opposite. Here is the adjacent. Now solving this problem, and it is correct, the instruction is correct to two significant figures, and we are asked to look for x. Now this problem now, you need to look at it very carefully and determine whether you are to use sine, you are to use cosine, or you are to use tangent. That's correct. So you need to know which of these values you are to use. So if we look at tangent, for instance, we have opposite over adjacent. So this is the adjacent, this is the opposite. We are asked to look for the value of x, which is in the opposite, but adjacent, there is no number, no digits, no figures, it is just vacant. Right? You notice that if you use opposite over adjacent, you will not end up getting your answer because there's no figure you're going to input. You are just going to get just x over 0. So it's not to be used. So we have cosine here. Cosine is adjacent over opposite. Adjacent over opposite, which is adjacent over hypotenuse. So adjacent over hypotenuse. There's value here, but there's no value here. We're not asked to look for the adjacent, but the idea is to look for the opposite. So, but when you look at the sign, we have opposite over hypotenuse. Opposite over hypotenuse is the ideal one to use because it covers the opposite in the given figure. So we say sine is equals to, so sine, the short form is to write sin, which is equals to sine theta. Okay, the reason why I have sine theta here is equals to opposite over hypotenuse. So hypotenuse. So the sine theta here, the theta here means the angle, so this is sine 55 is equals to x over 20. At this point now, what you have to do is to do a cross multiply. So you cross multiply this particular variable, multiplying this, and this particular variable multiplying this. So we make this over 1 so that it will balance. So when sine 55 times 20, obviously when this multiplies this, it will still give you x. So x times 1 is the x. So we just write x. So like 55, what will it give you? Remember, you can find the values of sine using your 4-figure table or your calculator. So when we say sine 55, you have 0.8192 times 20, which is equals to x. So 0.8192 times 20. I want you to check it right there in your calculator and tell me would be the answer. Correct. 16.384. 16.384, which is equals to x. I told you whether 16.384 is equals to x, you can still turn it this side. You still have x is equals to 16.384. Remember, the instruction is to correct two significant figures. So to correct this two significant figure, we say x approximately. Two significant figure will give you just two digits of number, that's 1 and 6, which give us 16 as our final answer. I hope this is clear. I would like you to please take a screenshot of this. We'll be going into another problem which is similar to test knowledge on. So please take a screenshot of this because I'm going to play the ball. When I play it, we'll be going into another problem. Okay, so let's go into another problem. Still on trigonometry ratio. Okay, still on trigonometry ratio. All right, this time we'll be looking at this particular angle. So we have this particular angle in here. It's 90 degrees. Supposedly here is 50 degrees, and the hypotenuse is 17 centimeters. Remember, here is the adjacent, okay? Here is the opposite, and here is the hypotenuse. So it can be either way. Even if you have a right angle triangle like this or like this. So whichever way they put it, just realize that it's still a right angle triangle. If it is like this, whichever way it faces, provided it's a 90-degree kind of right angle triangle. Okay. Right. Okay. So let's take a look at this. So we are asked to look for the unknown, and the unknown we are asked to look for y. The y here is posed at the adjacent. Remember, the instruction still remains correct to two significant figures. Correct? Two significant figures. Okay? So if we look at this problem now, we look at tangent. Tangent, for instance, captures the opposite over adjacent. So our opposite over adjacent. Opposite, there was no figure, no digits, and we are not asked to look for the opposite. But we are asked to look for the adjacent. So tangent is not a go-to in there. So we look at the cosine. Cosine here we have adjacent over hypotenuse. Here we have adjacent and we have hypotenuse. So we realize that cosine is ideal one to use in solving this. So we say cosine. This is the short form of writing cosine. So cosine is equals to remember is cos theta. You need to put cos theta. Remembering you have an angle here, which is equals to the adjacent. Adjacent we have here as y over hypotenuse as 17. So cos theta here is cos 50, which is equals to y over 70. Very good. You cross multiply. So here will multiply here and here will multiply here. So you make here to look like a fraction by putting over 1. So we have cos 50 times 17, which is equals to y, because y times 1 is still give you what? Y. Anything times any alphabet times 1 will still give you the alphabet. So now let's look at cos 50. What is cos 50? I want you to use your calculator, or if you have a 4-figure table, to check what is cos 50. When you check what's cos 50, you see it's 0.6428. So 0.6428 times 17, which is equals to y. So 0.6428 times 17. I want you to check it. What will you get? When you check 0.6428, you get what? What do you get? 0.6428 648 times 17, you get 10.93, which is equals to 1. So you say y is equals to, so this, so two significant figure is 2 digits, but you notice something here that this 9 is more than 5. So you take this one into here, which will give you 11. So here will be 11. Thank you very much. I want to believe you are now well cleared on this. So this is approximately 11 in two significant figures. Right. Thank you very much. If you have any question, feel free to ask. Right. See you next class.